All right, so we're going to start discussing our exponential growth and decay. So if you could copy this down in your notes, and then at the end of the note-taking process, you're going to upload a PDF of your completed notes. So we're going to talk about exponential growth and decay. And before we do that, let's go ahead and review exponential functions. So exponential functions are in the form of y equals a times b to some power of x. So x is going to be in that exponent. So it's important to know that a is going to represent the initial value. So when x is 0, then you are going to be able to find the y value, and that will represent a. And b is the rate of change. Basically, it's in a sequence when you're multiplying from term to term, it's what you're multiplying by. Okay, so that could either get bigger, which we would see as growth, or if you're multiplying by a fraction, that would indicate decay and you're getting smaller and smaller. So let's see how you would be able to do these. This is review. So at this point, we would be able to determine the equation. So see how far you can get on your own, and then we'll go over it. Okay, so the first thing you want to do from a table, well, regardless, you know that you're going to have to find the A and the B. Okay, now remember that the A represents the initial value. So the initial value is when x equals 0. So if we look at a table, I found where x is 0. So that means this 6 is my A value. Okay, so that means my 6 is going to go right here in the A spot. Now I've got to find B, which is the rate of change. So I need to figure out what it is that I'm multiplying by. So in order to get from 6 to 12, what did I multiply by? In order to get to 12 to 24, what did I multiply by? And then from 24 to 48, what did I multiply by? Well, sometimes it's really easy to see, oh, okay, well, I'm multiplying by 2. Okay, sometimes it's really easy to see that, and then I can go ahead and put that there, and then I'm done finding the equation. But let's say for just a minute, you didn't know that that's what it was. So what you do is you take the next term, and you divide the preceding term. So 12 divided by 6. You take the term divided by a previous term. So 24 divided by 12. 48 divided by the previous term. Okay, and so you're dividing by the previous term, and then that should give you your rate of change, and then that's where you're going to get that B value. Okay. Now let's take a look at what about from a sequence. All right, see if you can come up with the equation from a sequence. Okay, so let's take a look. Remember that you need AB to the power of X. And so we could see in the table that it was really easy to find the A value, but it's not really so clear on this sequence because this 20 is the first term, 10 is the second term, and 5 is the third term. So we would have to kind of go backwards to find out what would be the 0 term. So in order to find the A value, we would have to kind of go back a term on that. But that's not too difficult. Let's just see what the pattern is. So let's see if we can figure out what the pattern is here. Well, we would take 10 divided by 20, okay? 10 divided by 20. That looks a little weird, so I rewrite it as a fraction, and then I'm like, oh, okay, well, that's 1/2. Well, let's see if that holds true with 5 to 10. So 5 divided by 10, oh, that's also 1/2. So what I'm really multiplying by, notice that the numbers are getting smaller. So if they're getting smaller, I'm going to have a fraction. Okay, I'm going to have a number between 0 and 1. So that is a number between 0 and 1. So I'm good to go with that. I can also do this just to double check. I can go 20 times 1/2, right? So half of 20 is 10, which gives me that term. Then I could go 10 times 1/2. Well, half of 10 is 5, and it gives me that term. So I know I'm good. I know that the rate of change is 1/2. Now, the only other part that we have to figure out is the A value. So this isn't too difficult to figure out. I gave you somewhat of an easier pattern, right? If I'm going to cut every term in half, what do you think that term is going to be? If I take this term right here, which I don't know, and I multiply it by 1/2, and it gives me 20, right? So we could do this. We could figure, well, x times 1/2 equals 20. I could try to solve for x by multiplying by 2, right? Let's clean this up a little bit. 1/2 times x is 1/2 x equals 20. So I'm going to multiply by 2 to get x by itself. Whatever I do to one side, I do to the other side. So this guy right here that I said was x because I didn't know it is going to be 40. Now, obviously, I try to give you something that you could try to figure out on your own without going into this detail, but if you needed to, this is how you could approach it. All right, so that was review. Now we're going to go into specific growth versus decay. So we have our equation here. Just talked a little bit about it. If you're multiplying by a number greater than 1, so if your pattern was multiplying by greater than 1, remember here, my pattern was multiplying by 2. See, my B value is 2. That is going to represent growth. So if my B value is bigger than 1, it represents growth. Here's what it looks like in an equation. All right, that's my B value. And this is what the picture is going to look like. It's going to start off slow and then grow really, really fast. All right, then the other option is, what about if your B is in between 0 and 1, which is what we just had right here, where I saw that my B value was 1/2, and we noticed that the sequence was getting smaller. All right, so when it gets smaller, it's going to be decay. So here is an example of a B value in between 0 and 1, and then the graph. Okay, and you notice how this one is getting bigger. The Y values are getting bigger. And on this one, the Y values are getting smaller, right? Okay, so let's take a look at B values in terms of percentage. All right, so the B value is going to be calculated a couple of ways. It's going to be 1 plus the percentage rate. Now, sometimes that rate is a positive or a negative. So the rate is just the percent rate, and we want it in decimal form. All right. So the way that we're going to do that is either you could look at B as 1 plus the rate, or you could solve for R, subtract 1 to both sides, and get the rate as the base minus 1. So these are equivalent expressions. So what we're going to do is identify if the following is growth or decay, and then find the rate of increase or decrease. So I'm not finding the B value. The B value is right here. Um, and we look at the B value to find out if it's decay or growth, but the question's asking us for the rate of increase or decrease. So let's take a look. Hopefully you can determine if this is growth or decay. This is a number that's smaller than 1, so it's going to be decay. So there's two ways to kind of go about doing this. We could either write the rate is equal to B minus 1, which is what we had right here. To find the rate, you could take the base minus 1. So my base is 0.76 minus 1, which gives me a negative 0.24, which makes sense because the negative is going to tell me that it's decreasing. Okay, so it's decreasing, which would indicate decay. And then the 0.24 in percent form is 24%. So the rate of decrease is 24%. Now, another way you could have done that, and I say or, so it doesn't matter which way you do it, it said the base is equal to 1 plus the rate. Okay, that's right here. Base is equal to 1 plus the rate. So I have 0.76 because that's the base is equal to 1 plus the r. And solving for r, you would subtract 1 from both sides, and you still get negative 0.24 as the rate. Okay, so it depends on what you want to do with that, either or. Now we know the negative is going to indicate a decrease, so that's going to be a decay. And then the 0.24 in terms of a rate needs to be in percentage, so that's 24%. All right, let's have you try 2. Okay, so in number 2, I look at the b value. It's a number bigger than 1, so it's going to be growth. If I wanted to use the r is equal to b minus 1, I've got my rate is equal to my b minus 1, which gives me, look at that, it's a positive 0.08. So that means it's going to be an increase, and my rate is going to be 8%. So if you use the other formula, when I said or, this would be your technique. Base is equal to 1 plus r. My base is 1.08. Subtract 1 from both sides. My rate is positive 0.08, which would indicate, again, positive would indicate an increase, which indicates growth, and the rate in percentage form. All right, let's take a look at 3. Go ahead, try 3. Okay, hopefully you could see that this is a number smaller than 1. Let's go ahead and look at, before we determine decay or growth, let's go ahead and just find the rate of decrease or increase. So the rate is going to be 0.93 minus 1, which gives me a negative 0.07, which that negative is going to tell me that it's decay. And then the rate is going to be 7%. So let's take a look at if you did the b equals 1 plus r route. It would be 0.93 equals 1 plus r. Subtract 1 from both sides. We get the same thing, but remember the negative shows that it's a decrease, which is why I took this to be decay. And then the percentage is 7%.